In this lesson, we're going to review factoring. Remember, a factor is what we are multiplying together. So, in the first example, we wanted to just review FOILing, which we've been doing. So, x times x is x squared. X times 5 is 5x. 3 times x is 3x. 3 times 5 is 15. And when we combine like terms together, and when we write our quadratic in the correct order, we get x squared plus 8x plus 15. So factoring is simply figuring out what are we multiplying to get that. And so we're actually reversing our FOILing. So the way that we factor when our a is equal to 1 is simply we can set up our two set of parentheses. And then I have a method that I call the x. And we have our a, our b, and our c. So what we do is in the top, we multiply the a times the c. And in the bottom, we put our b value. And so in the other two parts of the x, what we're doing is we're looking for two numbers that multiply to be negative 20, but they will add up to be negative 8. So that would be negative 10 and positive 2. So we have x minus 10 and x plus 2. And these are the two that we put into the factors. So again, the top is a times c, and the bottom is our b, and the other two numbers become the part of our factors. So let's try it again. So we want to know what two numbers will multiply together to be 50, but when I add them together, I get negative 15. So we know that 5 times 10 is 50, and if we use two negative numbers, negative 10 and negative 5, when I multiply them together, I'll get positive 50, but when I add them, I get negative 15. So we have x minus 5 and x minus 10. Next example, we can use our x. We have our a, our b, and our c. When we multiply a times c, we get negative 16, and then when we get our b, which is 6, we want to know what two numbers will multiply to be negative 16, but add up to be 6. So if we take 8 times negative 2, we get negative 16, and 8 plus negative 2 will give us positive 6. And those are our two factors, a, b, c. A times c is 6, and the b value is 5. What two numbers will multiply to be 6, but add up to be 5 would be 2 and 3. So we have x plus 2 and x plus 3. But what happens if our a value is not 1? Well, we can do the exact same thing, we just have to add a step. So the first thing we're going to do is make our x, and we know that we need to do a times c. So a is 2, b is negative 11, and c is negative 6. So we have negative 12, and then the b value is negative 11. So what two numbers multiply to be negative 12, but add up to be negative 11? So that would be negative 12 and 1. So here's the step that we have to add. We need to make a box. And in the first section of first square, we're going to put our first term, which is 2x squared. And in our last box, we're going to put our last term, which is negative 6. And then we're going to use those circled two numbers to fill in our other two boxes. So it's going to be negative 12x and positive 1x. Then we find the greatest common factor of each row and each column. So 2x squared and x have an x in common. And negative 12x and negative 6 have a negative 6 in common. And then we have 2x squared and negative 12x would be 2x. And x minus 6, we just have a 1 in common. Those are our two factors. And we can check by FOILing to make sure that we have the correct answer. So 2x squared times x is 2x squared. 2x times negative 6 is negative 12x. 1 times x is x. And 1 times negative 6 is negative 6. And when we combine like terms, we get 2x squared minus 11x minus 6. So if we try the next one, the first thing that we'll do is we'll put our a times c in the top and our b value in the bottom. And we ask ourselves what two numbers will multiply together to be 12 and will add up to be 7. So that would be 3 and 4. But because the leading coefficient is not 1, we'll make our box. We'll put the first term of 2x squared in the first box and our 6 in our last box. And then we'll use the circled terms to put our 3x and our 4x, and we find our greatest common factor. So in the first column we have an x, in the second column we have a 2. Going across we have a 2x, and going across the bottom we have a 3. So those are our two factors, x plus 2 and 2x plus 3. All right, let's go down to the next example. We have some special patterns. If you remember, these are called the difference of squares. When you have the difference of squares, if it's a leading coefficient of 1, remember x times x is x squared, and what would we multiply together to get negative 25 would be a positive 5 and a negative 5. If you recall, the difference of squares are the exact same binomial, but one of them is positive and one of them is negative. So when we do x squared minus 9, we have x plus 3 and x minus 3. The exact same thing will go for our difference of squares when the leading coefficient is not 1. We simply figure out what times itself gives me 4x squared. So that would be 2x and 2x. And what times what would give me negative 9 would be a positive 3 and a negative 3. Again, what times itself gives me 121x squared, or you can say what's the square root of 121x squared. So we have 11x plus 4, and we have 11x minus 4. In the next set of problems, we have a perfect square trinomial. Perfect square means that it's going to be the exact same binomial multiplied times each other. So what times what gives you 4z squared? So that's going to be 2z and 2z. What times what gives you 9? That would be 3 and 3. But because the middle term is negative, these are both going to be negative 3's because a negative times a negative is a positive, and a negative plus a negative is a negative. And when you have a perfect square binomial, we can simply write it as the same binomial squared. In our next example, we know that the square root of 36w squared is 6w. And the square root of 25 is 5. And we know that our middle term is positive, so they both will be plus. So we have 6w plus 5, the quantity squared. All right, we also need to find the greatest common factor. So the greatest common factor means what do these have in common? They both have a 3 and they both have a y squared. So we're going to divide these both by 3y squared. So 6 divided by 3 is 2. and y to the fourth divided by y squared is y squared. 3y squared divided by 3y squared is 1. In the next example, the greatest common factor is a 3. When I divide by 3, I get x squared minus 4. However, we just finished the difference of squares, so we know that we can continue to factor as x plus 2 and x minus 2. But remember, we always have to keep the greatest common factor. It doesn't disappear. 6x cubed minus 15x squared minus 9x. All have a 3 in common and an x. So when we divide by 3x, we get 2x squared minus 5x minus 3. So we need to see if we can keep factoring on this one. So let's make our x, and it's only going to be for this part. So here's our a, our b, and our c. So we have a times b, 2 times negative 3 is negative 6, and we have negative 5. What two numbers can we multiply together that give us negative 6, but when we add we get negative 5? So that's going to be negative 6 and positive 1. But because the leading coefficient is not 1, we'll have to make our box. So we put our first term, which is 2x squared, and our last term is negative 3. We put our negative 6x and our positive 1x, and then we find the greatest common factor of each row and each column. 2x squared would be x, negative 6x and negative 3 would be negative 3. 2x squared and negative 6x would be 2x, and x minus 3 would be positive 1. So as we finish this problem, we have a 3x, and we have x minus 3, and we have 2x plus 1. And that is finding the greatest common factor and factoring completely. Now if you'll please finish by doing the student practice problems.